Okay, we were talking about the normal curve and it following that empirical rule. And with that empirical rule, one of the things that you have to remember is that the mean was in the center. And then we went 3 standard deviations out on both sides. So on this right side, we added our standard deviation. So we added 1 standard deviation, 2 standard deviations, and 3 standard deviations. On the left side, we subtracted our standard deviations. So this is 1 minus a standard deviation. This is our mean minus 2 standard deviations. And our mean minus 3 standard deviations. And then what this says is that between 1 standard deviation here, and I wish I could draw straight lines. Y'all know I can't. Between these 2 lines, we have approximately 68% of our data. So, because we're looking at this peak here. And if y'all recall, we could do half of that, which was 34% here. And then between these 2 lines, that included our 68%. And so we could do our dashed lines up here, and that was 95%. Okay, so that included the 68%, so we added a little bit extra. And then between these 2, we go out further, so that's more than 95. So this is our almost 99.7%. We don't use 100% because we always have these tails out to the left and the right where we have our possible outliers. So we don't really know where this is going to go. So the normal distribution is going to follow this empirical rule. And how we can change this right here is we're actually going to change from using the mean and standard deviations here to using what is considered our z-scores. And we're going to put a z-score of a 0 here, and then we're going to use +1, +2, and +3 like a number line, and a -1, -2, and a -3, again like a number line. But these are going to be z-scores. This is what's going to help us standardize this. And so let's look at the area under the standard normal curve. This is the normal distribution, and it can actually have any mean and any positive standard deviation, but we're going to change that to where we work with ones that have a mean of 0 and a standard deviation of 1, called the standard normal distribution. And the reason why we want to do that is basically we're standardizing this so that we can compare them. Okay? If something has a mean of 56 and another thing has a mean of 83, we can't really compare them. But once we normalize them or standardize them, we can. And so the x-axis will be indicated by the value of a z-score. And we have already discussed how to calculate z-scores. Z is equal to the value minus the mean divided by the standard deviation. And we'll be using this formula and this calculation in later sections. Today we're going to mainly pay attention to how do we interpret this normal distribution. And so I've written out the steps here, and we're going to be using table A2 from the back of your textbook. And this is what table A2 looks like. Okay, this is table A2. So go ahead and get out table A2. It has 2 pages. So first page has z-scores of negatives, and the second page has z-scores that are positive. And in the next video, we're going to talk about how to actually use this table.